All right, everybody, I want to run through and actually do the practice solution key to the exam, and here we go. So first, for part A, we want to actually calculate what's going on with this buggy. And to be absolutely clear, when we are doing a problem from the buggy lab, we have a position versus time graph. To get the speed, always get the slope. And in this case, I have 2 points right here. And I can call this point the x1 point or the x2 point and the y2 point. This would be the x1 point and the y1 point. But let's be really clear here. This should be time and position. I prefer those letters. And that's actually what I'm going to use when I calculate the slope. So the v is going to be the slope, which is the rise over the run. And that's going to be 25 minus 5 over 5 minus 0, which is going to be 20 over 5, which ends up being 4 meters per second when we get that slope. Now we want to know, is the buggy speeding up or slowing down? Let's remember this is a steady slope, and that implies that the speed is absolutely steady. So for part B, the answer is neither. It's actually a constant velocity. And then for part C, we want to know, where did the buggy start from? We read the initial position off the graph. X naught, the starting position, is the 5 meter mark. Now we ask for the equation of motion of the buggy. Now I saw a lot of people write this down. X equals v naught t plus x naught, which is the general formula. But what we're looking for is a specific formula. And in this case, that's going to be x is, and for v naught, we put in the slope, the time is t, and x naught is the initial position, which is the 5 meter mark. So this is what we want to write. Whoops. This is what we want to write for part D. For part E, we want to know where the buggy will be in 10 seconds using the answer to part D. So what we're going to do is we're going to say x is 4 times 10 plus 5, and we wind up at the 45 meter mark. Now to plot the velocity versus time, we know the velocity is 4 meters per second, and so at this 4 meter mark, we're never changing velocity, so it's just a flat line at the 4 meter mark across here. So flat. And that's problem number 1.